The most famous of all the continuous distributions is the normal distribution. The normal distribution has a couple of things that are always true about it. It is this beautiful bell shape. When we talk about a bell curve, we're talking about a normal distribution. Since it has this bell shape, it is unimodal and it is symmetric. And that mode is always at the mean. Since it's symmetric, the mean, the mode, and the median are all the same. And then it has a standard deviation that we can use to sort of measure how wide or how much spread there is in this distribution. And as we saw back in part 2, most of the time, almost all of our data falls within 3 standard deviations of the mean. And we even had that empirical rule, which is on the next couple pages, and I'm going to skip, that reminded us that there's the 68, 95, and 99.7. I think those are the right numbers. It's been a while since I've even talked about it, within each of those bunny hops away from the mean. We do have some new notation back in the binomial land. Remember, we used something that looked like this. X follows a binomial, n comma p. X denoted our random variable, the thing that we didn't know what was happening. And so it's kind of confusing. We do tend to use X a lot, just like we did in algebra and other math classes. So again, we're using X, our random variable here. But now this is not talking about a number of successes. This is just talking about some random variable that follows a normal distribution. I think my husband set off an alarm. Whew. All right, so this keyword of normal here is going to be what we're looking for to let us know we're using this in all of our questions. As soon as you see that, we know we're using the normal distribution. We should draw a cute little curve that's up there. So our notation here, X follows N for normal. And then the 2 things that we need to know about a normal, just like the 2 things that we need to know about a binomial were our number of trials and our probability of success. The 2 things we need to know about a normal, to know everything about it, are the mean and the standard deviation. So remember our good friend mu and sigma, those Greek letters, to denote the real deal mean and the real deal population standard deviation. When we talk about standardized test scores, or we're actually trying to figure out, in this case, the standard normal, which is a z-score. Our z-scores follow a normal with a mean of 0 and a standard deviation of 1. So if you remember our z-score formula from back in part 2, x minus mu over sigma. So those of you who take in pre-calc, you can see the 2 transformations here. We're taking something centered at the mean, we're subtracting it off, so it's going to be centered at 0, we're shifting it left, and then we're dividing by our standard deviation, so we are shrinking or stretching this in a way that we can actually have it have a standard deviation of 1. So we're taking this and we're dividing it and making it 1. So if you drew your standard normal curve, it's always going to look something like this. Mean is 0, and then everything is within 3 standard deviations. Almost everything is within 3 standard deviations of that. So anyways, that's the brief intro to what the normal distribution is about. I'm going to skip the empirical rule, and I'm going to make you a quick video showing you how to use the table to find probabilities. You do not need to watch that video if you don't want to use the table, but I'm going to give it to you because that's what my next video talks about.